Okay, we're going to start looking at the Module 3 application problems. And I'm first going to do an overview, and then I'll let you guys tell me which ones that we may want to work, okay, if you want any extra reinforcement. So I'm going to go into, and I'm going to click on the application problems, and I'm going to click on our PDF here. And this is going to list the problems that we have assigned out of our book. So you'll notice they start on page 47, and I did list for us the part A, part B answers for each one of the problems. Now, I want to reinforce again, these are the answers from the back of the book. I do get similar answers, but if you're working, you know, more decimal places, you'll have a little bit of difference here, and that they always are going to be rounding their final answer to like 3 significant digits. Okay. So if yours rounds to very close to this, great. All right. Then you're in good shape, but you may not get exact, and that's okay. So let's look at, you know, starting on page 47, we've got 32, 34, 36, 38, and then 44. So I'm going to go underneath, and we're going to look at the top here of page 47. Your first problem is going to be number 32. Okay, so number 32 says we have 2 cables that are tied together at point C. And they look as you can see here. So knowing that alpha is 30 degrees, that's right here. Okay, determine the tension in AC and BC. Okay, so as we look here, imagine that you're going to be putting, you'll see that everything comes together at that point C. So that's going to be like our origin of our X and Y axis. Okay, and so you can kind of, you know, you can draw an X and Y axis here. So I've got a Y axis and I've got my X axis going right through here. Okay, so that means that our 6 kilonewtons is going to be going straight to the right. Okay, and then our force going up to A is going to be along that cable. So they're giving us the angle of 55 degrees. So that means that this is a different degree. This is not 55 degrees to the horizontal. Okay, so make sure you check your angles here. It's going to be along that cable, and it's going to be pulling away. Okay, pulling away. So you're going to have a vector that's going to be going up and to the left. And then you're going to notice that down here for C to B, alpha is here. So that is not this angle coming from the horizontal. It's this one coming from the vertical. Okay. And then this also is in tension. It is going to be pulling from C towards B along that cable. Okay. So as you can see here, if I want to determine what the force is in AC and in AB, I'm going to need to break it into its components, put it in terms of its hypotenuse, and then solve using our equations of equilibrium. This one will be a 2 equations, 2 unknowns. Okay, 2 equations, 2 unknowns, just so that you kind of are anticipating that. Now, what I will do after we do this overview, we will take individual questions, you know, on problems that you feel like you want to get started on, and that's totally fine. So we're just going to kind of go through and see what these are all about. Our next one is going to be number 34. Number 34 is this one right here. Here again, everything's coming together at C. That's our concurrent point, if you would, the point of application. So you could show a Y and an X axis going right through the middle there. All right. And then we're going to have a force coming straight down. Now, this force coming straight down is not going to be 50 kilograms. Why? It's a weight. So why can't I just put 50 kilograms going straight down on a vector? Why can't I do that? It's not, it's mass. It's mass, right? And what is mass? Is it a vector quantity or a scalar quantity? Scalar, okay? And I've seen students, they're like, well, why can't I just put the 50 in here and then just on my very final answer, it'll be the same. I can just do it there. Because you don't represent a mass with a vector. That's why. And I'm going to be really kind of picky on that. Okay. So you need to convert this to force and put it in newtons, and then put that number at the end of the vector that's going to point down, representing the weight of that block. Okay. And to calculate that weight, remember, it's going to be WT is equal to mass times gravity, right? So you're just simply going to multiply that by 9.8, but make sure you put your units in there. Okay, I look for kilograms and I look for meters per second squared, because a kilogram meter per second squared is a Newton, right? Yeah. I know, it kind of sucks. I was a physics teacher at my other school, yeah.
So, how do you know exactly which, I know they make it obvious. They're like putting the arrows on, like in my mind, when I look at that picture, the weight is pulling down
Mhm.
on A.
Mhm.
So like in my head, the arrow should be going from A to C.
No, it's the reaction. What that cable has to do to keep that from falling. It has to pull up because the force is going down. Good question, Lex. Thank you. And you know what? We haven't gotten a whole lot. They haven't really talked too much about how do we represent the reaction of a cable or a rope. In the next unit, that's when we start doing that, when they formally start doing it in our book. So that's why I've been kind of giving them to you as we go along. But yeah, so Lex's question is, if this is pulling down, I feel like this should come down with it. That's what it's going to want to do. But in order for it not to fall, okay, then A has to be pulling up. A has to be pulling up, and B is going to be pulling away as well. Yeah, yeah. Because it's a reaction of the cable to support this through that condition of equilibrium. It's got to balance. Okay. All right. So here you're going to show this going up and to the right from C and down into the, I'm sorry, up and to the left, down into the right here. Okay. In tension. Pulling away in each case. And then you're going to have this force going straight down, but it's not going to be 50 kilograms. It's going to be whatever your weight is, and you're going to put it in newtons. Okay. And then the process becomes the same. Anything that's not on the X or Y axis, you resolve into components. Using those components, you use your equations of equilibrium, and then you see where you're at. And you're probably going to have two equations, two unknowns for this one. I'm anticipating. Okay. All right. So that's that one. The next problem we have is number 36. Number 36 is at the top of the following page. Okay. And here we've got two cables are tied together at C. Okay. And they're loaded as shown. P is 500 newtons and it's at an angle of 60 degrees. So here again, we have point C that is kind of like the center of everything. That's our concurrent point. So we would start by showing our X and our Y axis going right through C. Okay. And then we're going to show again, coming from C going up to B, a force going up and to the right. And you can't see it because it's kind of force going up and to the right. I think you can see it a little better there. And a force going up and to the left along A here. I don't want to use a pen because I want to be able to erase a little bit later. And then here you'll notice that our P will be known. It'll be 500 at an angle of 60. So you have three forces now to break into components, two of which of those components you will know the actual magnitude, and that's going to be Px and Py, right? Those will be actual numbers because we know P is 500 and it's at a 60-degree angle where alpha is, okay? So then you will sum your forces in the X and Y. You'll probably have two unknowns again, and then you'll use your two equations, two unknowns to solve. You're going to get really good at that, okay? All right, the next problem is number 38. Number 38 says we have two forces, P and Q, they're here and here, and they're applied as shown on the bracket. P is 600 and Q is 800. Okay, so those are known quantities. We want to determine what are the tensions in rods A and B. Now they're calling it tension in the rods. If you want to call it just A and B, that's totally fine. I like to keep it simple. I don't need to put T, A, X, T, A, B. But it's up to you. If you want to follow what they're doing, that's totally fine. So you're going to notice here that they're showing you the directions. Here is the point where the concurrent forces are all coming together. And now you've got your two unknowns and you want to solve for those two unknowns using the condition of equilibrium and the process that we've been looking at. All right, I think you get to do one more. Let's do one more. So this is going back to problem 36. Problem 36. So this is number 44, but looking at problem number 36, okay? They're giving us this time the tension in cable AC is 600 newtons. So the last time you had to solve for it. You knew what P was, but you had to solve for A and C. This time they're giving you the tension in C, A to C, and the tension in B to C. Okay, so they're still gonna be pulling away just like they were, but now this one is 750. And the other one, up to A is 600. Okay, so we know those forces now. So when we break them into their X and Y components, we'll know the numbers, right? And what they're saying is here, determine what is force P. Okay, what is force P? And then what is the angle that it's at? What is alpha? That's your little bit of a challenge problem. All right. Go about the same exact process that we have been. All right. And it might like reveal itself when you get there, but it is a little different than the ones that we've been doing, but it's not hard. And so that one, if you have any questions on it, I want you to like try it a couple times, and I won't answer on 44 until Thursday. Does that sound okay? All right. Otherwise, all the other ones are available. Okay. So, so that's what we have for homework tonight. So before I kind of let you start working, are there any of those besides number 44? Are there any of those that you want to get started on? Or do you feel like, I think we have enough? Does anybody want to see, you know, number 32? Raise your hand. Anybody want to see number 32? And I'll watch the chat. Okay. Does anybody want to see number 34? It's this one here. Okay. Does anybody want to see number 36 as written? This one's where we know P and we're going to be solving for A and B. How about number 38? And number 44, we're going to save. I'm going to save that one. Okay. Then if that's the case, I'm going to let you guys work independently. And then I'll be here to answer questions. So I'm going to stop the recording at this time because I'll post this, you know, for an overview.